Hi, and welcome to a brand new course on Google Cloud Run. In this course, we'll cover Google's serverless container orchestration service, Cloud Run. Cloud Run allows you to run your containers without the hassle of managing underlying infrastructure. You can bring a container with any programming runtime and Cloud Run can run it. Your application can start serving traffic within seconds. In this introductory video, we'll take a look at all the features the Cloud Run has, and then we'll cover them in depth in subsequent individual videos. So let's get started. First, we'll cover the types of workload. Cloud Run supports two types of workloads, Cloud Run services and Cloud Run jobs. At the time of making this video, jobs are in beta. Services allow you to deploy web services, web applications, and REST APIs. Basically, any application that can serve web requests. Whereas, jobs allows you to run containerized batch workloads. Cloud Run has recently announced 2nd Gen execution environment, which has faster CPU, faster network, full Linux compatibility, and network file system support. However, this environment is still in preview at the time of making this video, and 1st Gen is still the default environment. Apart from serving web requests, your Cloud Run containers can also service events. Cloud Run integrates with EventArc, which is a Google Cloud standard of triggering services based on events. These events can be happening across all the Google Cloud services. So for example, you can trigger your Cloud Run service on a GCS event, let's say creation of an object, or a PubSub message. This triggering capability allows you to build event-driven workflows using Cloud Runs. Cloud Run also allows you to define resources for your containers. You can configure both CPUs and memory requirements for your containers. Cloud Run has multiple models for CPU allocation to your application, depending on the needs. You can either have CPU allocated to your container when it's serving a request, or you can have CPU always allocated. Not just this, Cloud Run has recently announced Startup CPU Boost to allow for faster startup times of your containers. It gives more CPU to your container when it's starting up to allow the container to run the setup code faster, and this leads to smaller startup times. Cloud Run also provides fine-grained concurrency controls so that you can eke out the maximum performance from your instances. Cloud Run has constructs such as min instances, max instances, and max concurrent requests to tune the level of concurrency. Cloud Run has a concept of service revisions where you can have multiple versions of the same service deployed. So if you deploy a newer version of a container, it becomes a newer service revision. Combining this revision with the traffic management capabilities that we'll discuss shortly, you can do gradual rollouts or A/B testing of your services. Traffic management constructs allow you to define rules around traffic routing to different versions of your service, giving you full control. So for example, you can route 100% traffic to the newer version, or you can have a gradual rollout, say 5% to newer version and 95% to old version. And in case of a bad version being deployed, you can also revert 100% traffic to the older version. In last, the authentication. Cloud Run supports different ways to authenticate users and services. So for user authentication, you can either use identity-aware proxy for internal users or identity providers for external users. Whereas for service-to-service authentication, Cloud Run has constructs of passing tokens, which we'll discuss in the individual video when we'll do hands-on labs. So each of this feature will be covered in a dedicated video, and each of those videos will have hands-on labs because this course is not just going to teach you the theory but also the practical bit of it. And I can't wait to share my learnings of Google Cloud Run with you in this course. That's it for this video. Please hit like if you liked the content and consider subscribing and commenting to make YouTube algorithm happy. And I'll see you in the next video.